there, Mrs. Lopez here, and we are working on our second part of lesson 2 in exponential notation module. Um, in our previous lesson, we talked about multiplication using the same base and different exponents. So just to recap, if I had 3 to the fifth multiplied by 3 to the seventh, uh, it only looks like 3 multiplied by itself 5 times, multiplied by 3 multiplied by itself 7 times, right? So we will have 3 to the power of 5 plus 7. We will have 12 threes multiplied by itself, right? So 3 to the 12th power. Okay, so now what happens when we divide numbers with the same base and different exponents? So let's talk about division today. Okay, let's say I want to divide 3 to the 7th by 3 to the 5th. Let's see how it looks first in the expanded notation. So 3 to the 7th is 3 times 3 times 3 times 3 times 3 times 3 times 3. Okay, so this is 3 to the 7th. 3 to the 5th, 3 times 3 times 3 times 3 times 3. All right. Now, when we think about this, I can separate all of these threes and put them in a different fraction, right? So what I will get here is 3 over 3 multiplied by 3 over 3 multiplied by 3 over 3 here and here. Okay. Any number over itself is 1, right? We know from this from probably grade 3 or 4 when we have a number over itself and it's 1 whole. 3/3. I can simplify them, right? It will make 1 whole. And we know that number 1 multiplied by itself, no matter how many times, it's still going to be 1, right? So what I have left is 3 times 3 over 1. Okay, so that it really is 3 to the second power, right? Or it can be 9, but the point for us is just to see what the exponent is going to look like. Okay, so let's try one more. Let's do 2 to the 10th divided by 2 to the 5th. Okay, I'm going to rewrite it in expanded form. Okay, so here I have 2 to the 2 to the 10th power divided by 2 to the 5th power. Again, any number over itself is going to make 1 whole. So I can just simplify these 2's until I can't anymore. Okay, and what do I have left is 1, 2, 3, 4, 5 times when 2 is multiplied by itself. So this is 2 to the 5th. Let's try one more. Let's do 4 to the 2nd divided by 4 to the 6th. Okay, again, I'm going to rewrite it in expanded form. All right, so this is 4 to the 2nd divided by 4 to the 6th. And again, I can simplify my pairs that make 1. What I have left is 1 over 4 to the 4th. Okay, so from here, I can make a rule, right? What do we have here? I have 3 to the 7th divided by 3 to the 5th is 3 to the 2nd. 2 to the 10th divided by 2 to the 5th is 2 to the 5th. 4 to the 2nd divided by 4 to the 6th is 1 over 4 to the 4th. What that really is, I really am just subtracting these powers, right? So I can say that any number x to the mth power divided by x to the nth power is going to equal x to the power of m minus n. We are subtracting the exponents when we divide numbers with the same base. Okay, time to do some exercises. Um, we will have numbers from exercise 21 until exercise 31. Exercise 32, we are going to skip. We don't need that. So let's go ahead and get those exercises, pause the video, and then come back to check the answers. Okay, so here are the answers. 7 to the ninth divided by 7 to the sixth is the same thing as 7 to the power of 9 minus 6, which is 7 to the third. Exercise 22. Negative 5 to the power of 16 divided by negative 5 to the power of 7 is negative 5 to the power of 16 minus 7, which is negative 5 to the ninth power. Make sure to put parentheses around negative 5. Exercise 23. 8 to the fifth to the power of 9 divided by 8 to the fifth to the power of 2 is the same thing as 8 fifths to the power of 9 minus 2, which is 8 fifths to the power of 7. Again, make sure to put parentheses around 8 fifths because the whole fraction is taken into the power. Exercise 24. 13 to the fifth divided by 13 to the fourth is 13 to the power of 5 minus 4, which is 13 to the first power, or simply 13. Next one, number 25, a over b to the ninth power divided by a over b to the second power. Since these are not numbers and just letters, it's still the same thing. It is the same base taken to the power. So we can tell it's a over b to the power of 9 minus 2, which is a over b to the power of 7. X to the fifth divided by x to the fourth, exactly the same thing. No matter what number x is going to be, it's still going to be the same base. So we are going to subtract exponents, resulting in the first power of x, or just simply x. Number 27, 2 to the seventh divided by 4 to the second. I just rewrote to explain you how they got 2 to the fourth power from here. 4 is 2 to the second power, right? 4 to the second power is 2 to the second power multiplied by itself, right? So that makes it 2 to the fourth, 2 plus 2 here. Okay, so here they changed 4 to the second into 2 to the fourth, and then they subtracted the powers. 7 minus 4 is 2 to the third power. Exercise 28 is just like the previous one. They changed 27 into 3 to the third power. And then since we have the same base now, we can only subtract the exponents. 3 to the power of 23 minus 3 is 3 to the power of 20. Exercise 29. Here we are dealing with numbers that don't necessarily have the same base, so we have to chunk it out. So we will have 3 to the fifth divided by 3 to the second, and we'll work with that first. And then we will work with 2 to the eighth divided by 2 to the third. Okay, we are only subtracting powers all the numbers that have the same base. So we will get 3 to the power of 5 minus 2 multiplied by 2 to the power of 8 minus 3. And that is 3 to the third times 2 to the fifth. Same's happening for exercise 30. We are subtracting powers of the numbers with the same base only. So negative 2 to the power of 7 minus 5 multiplied by 95 to the power of 5 minus 4. So we will get negative 2 to the second power multiplied by 95. And I wrote first power, but again, if a number written by itself just once, it's the first power. We don't have to put exponent on that. Last problem here, exercise 31. This one is a little bit trickier, so let me take some time to actually explain it to you. 5 over x to the third multiplied by 3 times x to the 8th. I can write 3 over x, 3 times x to the 8th over 1, right? That is not going to change a thing. And then I can put them on as one big fraction, right? So 5 times 3 times x to the 8th divided by x to the third times 1. Okay, so here I see that I can multiply 5 by 3 and I will get 15. And I will get x to the 8th over x to the third, and I can subtract these powers. So I will get 15x to the power of 8 minus 3, and that is 15x to the fifth. I don't need to put parentheses around 15x is because the power is only applied to the x and not to the 15. Problem B, 5 over x to the third multiplied by negative 4x to the sixth. Same exact concept. I'm going to put 1 as a denominator, and I'm going to put them as a 1 fraction, and I will be able to multiply 5 by negative 4, and then I can subtract the powers of my x's. So I will get negative 20 to the power, negative 20 times x to the power of 6 minus 3, which is negative 20x to the third. Again, I don't need to put parentheses in here because third power is only applied to the x and not to anything else. Last one here, 5 over x to the third multiplied by 11x to the fourth. Again, exactly the same concept, 1 underneath 11x to the fourth, and then you will see that you can multiply 5 by 11 and then subtract the powers of x. So it will be 55x to the power of 4 minus 3, which is 55x. Okay, so these are the exercises of the lesson 2 in the module 1, multiplication and division of the numbers with the same base and different exponents. So if you have any questions, please let me know. You know how to reach me, and I will talk to you in the next one.